10.5, counting problems involving not and or. So when looking at complements, principle of counting, the number of ways in which a certain condition can be satisfied is the total number of possible results minus the number of ways the condition would not be satisfied. Symbolically, if A is any set within the universal set U, then the following formula holds. Cardinality of A is equal to cardinality of the universal set minus cardinality of A prime. Let's do some examples. A proper subset of a set S is a subset that is not S itself. So for the set S, which is equal to A, B, C, D, E, F, the number of subsets is going to be 2 to the n. And in this case, we have 6 elements. So 2 to the 6, which is going to be 64 subsets. Number of proper subsets is going to be 64 minus 1, which is proper subsets. Another example. If 4 fair coins are tossed, in how many ways can at least one tail be obtained? By the fundamental counting principle, if 4 fair coins are tossed, there's going to be 16 different results. Of these 16, there will be one set that will be completely heads. So we subtract that from the 16, and we will have 15 different ways where there will be at least one tail. Moving on. Another example is Carol and her 3 friends are boarding an airliner. There are only 10 seats left, 3 of which are aisle seats. How many ways can the 4 friends arrange themselves in available seats so that at least one of them sits on the aisle? And from the word arrange, we can tell this is a permutation question. And the solution is as follows. At least one aisle seat is the opposite or complement of no aisle seats. So the total number of ways to arrange 4 people among 10 seats is going to be $5,040. So total number of ways to arrange them in all 10 seats. The total ways to arrange 4 people among 7, which are non-aisle seats, is going to be, from 7 seats, we choose 4, which is going to be $840. From the complements principle, the number of arrangements with at least one aisle seat is followed by subtracting both of these. $4,200 different arrangements with at least one aisle seat. Problems involving or. The complements principle is one way of counting indirectly. Another technique is to count the elements of a set by breaking that set into simpler component parts. If S is equal to A union B, the cardinal number formula from earlier says to find the number of elements in S by adding the number in A to the number in B. And then we subtract the number in the intersection of A and B if A and B aren't disjoint. But if they are disjoint, the subtraction is not necessary, and the following principle reflects the union/or/addition correspondence from. the additive principle of counting. So, the cardinality of A union B is going to be n of A plus n of B minus n of A intersection B. If they are disjoint, then it's simply going to be n of A plus n of B. So let's do an example. How many 5-card poker hands consist of either all clubs or all reds? So, the n of all clubs or all red cards is equal to n of all clubs plus the n of all red cards. And because there are 13 cards that are clubs within a 52 card deck, and we need to choose 5 cards from it to have a hand, it'll be from 13, we choose 5, plus all red cards, there's 26 red cards in the deck, we choose 5. So that's going to be this formula right here.